guys, welcome to topic 8. I wanted to kind of go over the equations with you. Most of these are ones we learned early in the year, but that doesn't change the fact that we forget things. And as you guys so wisely pointed out on our Google Meet last week, the negative numbers and the variables and what do I do next is kind of all a lot at once. So I wrote down 4 problems here, all really good examples of today's lesson. And I'm going to kind of talk through the vocabulary as I do them. So in this first one, n, a number, minus 5 equals negative 2. So something combined with a negative 5 would equal negative 2. You can probably do it in your head. But how do you prove it? Well, our first goal in solving any equation is to isolate the variable. N needs to be all by itself. So I'm going to keep my equal signs lined up. And if I want n to be by itself, I have to get rid of this negative 5. Well, the opposite of negative 5 is positive 5 or plus 5. So I would be using the addition property, okay, and finding a additive inverse here. If I add 5 to one side of an equation, I need to add it to the other side of an equation. A negative 5 and a positive 5 make nothing. So on this side of the equation, I have n. A negative 2 and a positive 5 make 3. So the value of n is 3. Okay. Now, this next one is really, really ugly. It has a decimal inside of a fraction, which is just, wow. Please remember that anytime you have this fraction bar, that just means division. So this is saying that y divided by 1.75 equals 4. Well, we just don't know what y is. So again, we're going to use an inverse. We're going to use the opposite. So right now I have division happening, which means I want to use a multiplication property. If I multiply both sides of the equation by 1.75, when we multiply fractions, remember, we can just cancel these two out. So we're left with y equals, well, 4 times 1.75 and feel free to use calculators if you want to. You should be able to do that one on paper, but I can't do it in my head at this point on whatever day we're on. So the value of y is 7. Now I could prove it was true by saying if I divide 7 by 175, I get 4. Okay, so the opposite of negative is positive. The opposite of division is multiplication. Well, on this next one, 5y equals 35. There is an implied multiplication symbol in there. It is saying 5 times y equals 35. Again, you can probably do this in your head, but let's prove it. So 5 times something. Well, I need to get y, the variable, all by itself. The only way to undo multiplication is with division. So I'm going to divide by 5. I'm going to divide by 5. I love to show my division as a fraction. Sometimes you'll see it with the division symbol, and that's not wrong, but this is really clean and neat and easy. 5 divided by 5 is just 1, so I have 1y. 35 divided by 5 is 7, which most likely is the number you were thinking of. Now you can prove it. Okay. Now, so far I've kept the variable as the front. That doesn't always happen. Y plus 22 is the same as 22 plus y. My goal is still to isolate the variable. So I'm going to keep my equal signs lined up. Right here I have a positive 22 that I want to move away from the y. In order for it to be gotten rid of, I have to do the same thing to both sides of the equations. So negative 22 equals negative 22. I'm keeping everything balanced. Y equals, once again, 7. So this is a review of something we did early in the year, but that doesn't mean that you remember. Hopefully this gives a nice refresher. I miss you guys. Have a great day.